Hi everyone, I'm Charlene.
And I'm Sierra.
And we are chemistry graduate students here at Cornell, and our research involves the use of radioisotopes.
We developed this kit to help students learn about isotopes and radioactivity in the classroom.
So when you receive this kit, these are the materials that you'll need when performing this activity. So first off, we include this game board. So it says Isotope Rummy on the top. And what you'll want to do is tape this down for each station.
Along with each board, there are cards that go along with each of the elements listed on the board. There will be 3 cups and 2 dice in here to play the game, along with 2 different colored sets of marbles.
Finally, we have a folder labeled Isotope Rummy, and in here there will be a variety of different materials that you can use, including a scoring, status tracker, a cheat sheet, some game rules, and a few other items that you can use for the activity. And we also included a set of dry erase boards with.
Okay, so here we're going to show you how to set up the game. So the game is going to come with about 5 different game boards and sets of cards. So that allows about 6 to 8 students to play per classroom. So first you want to do is you want to take out all the cards and separate them by their elements. So like we have helium, lithium, and then put those in order of what their atomic mass is. So once you have those laid out, you also want to separate the wild cards and the stable cards.
So from here, we've taped down the game board, and as you can see on the bottom here, we have labeled what the clear marbles and blue marbles are. So protons are the clear marbles, which will be in their own bowl, and the neutrons will also be in their own bowl. In the middle, we have what we call the atomic bowl, and this is the element or the isotope that you are currently on. So to start, we ask that you begin with neon 20, and that is already written on the isotope status sheet. So you'll want to make sure that there are 10 protons and 10 neutrons in here. So that is how you first set up the game.
Okay, so now we're going to teach you how to actually play the game. So the point of this game is to be the first person to get 100 points. So we're going to do that by getting different cards.
Right, so each of these cards represents a different radioisotope. So just a generic one, we have beryllium-8, and you'll want to show the students what each of these numbers mean. So you have the atomic number versus the mass number, and of course beryllium is the element. These cards have different labels on them. Some of these cards don't have anything like beryllium-8, whereas some other cards have stable written on the top. And some other cards have a star, or they have both a star and the word stable on them. These cards have different properties, which the students will get to look into based off their wild cards. So the stars represents wild cards. For instance, hydrogen 1, if the student gets hydrogen 1, they can pull up a wild card labeled hydrogen 1. And on the back there's a fun fact about this isotope, and there's an action they can do in the game. Also, if they pulled hydrogen 1 and it's stable, they also get to draw from the stable cards pile. And there's an action on here that they also get to do. Like Sierra said, the objective of the game is to get 100 points or more in order to win. And she will talk about the scoring a little bit.
So like Charlene said, there's different cards, and each card corresponds to a different amount of points. So these plain cards are worth just 10 points. The wild cards with a star, those are worth 20. And then the stable cards are worth 30. And then we also have stable and wild cards, such as hydrogen, so that would be 40 points. So really you want to get the most points by getting more stable or more of these wild cards. So what we're going to actually do now is you would go through and play the game. So the kids can decide when to start, what they want to start with, when their first birthday is, and go around clockwise or counterclockwise. And so what you're going to do is you're going to take turns rolling the dice. the dice will correspond to the number of either protons or neutrons you want to add or subtract from the bowl. So again, the point is to reach either, to get the most points. So maybe get a stable isotope, for example. So if you get 3, you would add either protons or neutrons, or you can do both, but you need to decide whether you want to add or subtract from the bowl.
And you can use the status tracker to help you keep track of what atomic number you're on. So we'll always start with neon 20, and if you wanted to add 3 protons, you would write +3 and then the number 13, because 10 plus 3 equals 13. And 0 and 10 for neutrons, and then determine which radioisotope you are currently on.
And then based on what you added into the bowl, you would add up your atomic mass, figure out what your atomic number is, and then find that corresponding element in the cards. And then the student would take that cards and record the number of points on their whiteboard.
Okay, so we are going to show you how to play the game now. Depending on your class size and the time restraints that you have, you can either have your students playing individually or in pairs. That's completely up to you. So first we start with neon 20, and you can have the students figure out who goes first based on their birthday. And then you can roll. I rolled 12. So I know that stable cards have more points, so I'm going to try to keep track of which of these is stable. So we have this cheat sheet here, and as a reminder, we have the mass number and the atomic number shown. These are all our stable isotopes, and on the back we have the wild card isotopes, and we also have a list of the mass ranges so that students try not to go beyond the scope of this game. So I know that with neon 20 here, if I add, say, maybe 6 and 6, I might have a stable isotope. Let's see from there. So add 1, 2, 3, 4, 5, 6, and then 2, 3, 4, 5, 6. After adding the marbles to the atomic bowl, I will start to fill out my status tracker sheet. So initially we had neon 20, and I added 6 protons, and I added 6 neutrons. So now in my bowl I have 16 protons and 16 neutrons. In total, the mass number is the number of protons plus the number of neutrons. So here I have 32. Now I need to determine which isotope I've landed on. So to figure that out, I determine the number of protons, which is 16, which will be sulfur. And the mass number is 32, so I need to look for sulfur 36, which by this cheat sheet I already know is a stable isotope. So I'm going to write sulfur, 32 actually, excuse me, also a stable isotope. So sulfur 32. So now I have a stable card, and it's Sierra's turn.
You get to draw a stable card.
Oh, that's right. So after getting a stable card, I can draw from the stable card pile and do the action. So this action is a -1. It says skip your next turn. So Sierra gets to go twice.
And then we'll just keep track of our points on this board. So Charlene, how many points do you have? 30?
I have 30.
Okay, so now we're going to show you what happens if you roll a wild card. So I ended up on 4. So I realized that I want to try to get a wild card. And one of the closest ones to get is chlorine 36. So I added 1 proton into the bowl and 3 neutrons. So now I have chlorine 36. And we see that it has a star at the bottom, so then I find the corresponding element in the wild card pile. So chlorine 36, that's the last one. And then I'll just read what it says on the back. So the fun fact says, chlorine was originally produced in the 1950s by irradiation of seawater from nuclear bombs and is now used for geological dating. So this just helps the students learn a little bit about the elements and the isotopes while they're playing the game. And then the action says, change the isotope in the bowl with one that you have in your deck. So that would be looking through your own cards that you already have and changing the isotope. Now, since I only have chlorine, the students can pick if they want what they want to change the isotope to. And this can kind of make it harder for the next person to get a stable isotope.
So now you have 20 points.
So now I have 20 points. Okay, so because Charlene got a negative stable card, that means I get to go again. So I rolled an 8 here, and I'm going to show you what happens if we subtract, say, neutrons out of the bowl. So 2, 4, 6, 8. So I have still the same number of protons.
So we're going to write 0 and then the number, so 17, and then you subtracted 8, correct?
Yes.
So now you have 11 neutrons. 17 plus 11 is 28. So that would be chlorine 28.
Okay, so this is the top card right here. So I have no actions here, so I'll just add up my points. So that will be 10 points for me. And then
And now it's my turn again. Okay, so it was back to my turn, and I rolled a 12. And from here, I decided to subtract 9 protons and 3 neutrons, which ended up being oxygen 16, which I have now another stable card, and that's an additional 40 points. 30 points. So I just also wanted to point out that sometimes students will roll and instead of landing on a potential card, they will go out of the range. Once again, the cheat sheet has the different ranges per element on here, but sometimes students will go way too far out of range. And because of that, they will not get any points. They will just have to go on to the next round.
okay, so now it's my turn, so I'll roll. I magically got 2. So now we have oxygen 18 in the bowl. And then I'll find the card over here. So oxygen 18. So I have a stable and a wild card. So I got lucky and I get to draw both. So there's oxygen. So this fun fact says used as biological tracer for studies in photosynthesis. And then I get to trade one of my cards with any player. So I get to choose what I want to swap with. So I probably want to trade my non-important card for one of Charlene's stable cards. So then we'll switch. Charlene will then lose 30 points. And gain. I will gain 30 points.
And I'll gain 10.
And you'll gain 10, sorry. Yep, so you'll gain 10.
Yeah.
Okay. And then I also get to draw a stable card. Oops, this one. And then my action is go again. So I get to go again. Sorry, Charlene. Okay, so by this point in the game, I have 50 points and Charlene has 40. So if you're limited by time in your classroom, you can just stop the game whenever, or you can go longer till somebody reaches 100 points. So based on that, I have won. And now, sorry, Charlene.
That's okay. So after the game is complete, we have activity sheets that are included in the red folder that comes along with the kit. And the students can try to fill this out. There are different questions on here to make sure that the student now understands what radioisotopes are, see if they can name some interesting properties of different isotopes or what the differences between isotopes are in general.
So we also have a couple videos for you that teaches the students about fluorescence and radioactivity, and those are just going to be activities for your classroom, not actual games.
So those would be more like demonstrations rather than a hands-on activity for the students to do.